Hello, welcome back. In this segment, I want to talk about an interesting issue when you use there exists in predicate logic. There exists is a simple idea, but if you model it incorrectly, you have a totally different meaning. Consider this example. Some camels or ducks. This is clearly a false statement. As far as we know, no camel is a duck. But let's make a statement, some camels or ducks. How would you model it using predicate logic? Let's consider C of x as a predicate, x is a camel, d of x is another predicate, that x is a duck. Yeah. So some camels or ducks, how do we do that? There exists some x is object, general object, such that C of x is true and d of x is true. That is the meaning of some camels or ducks. Okay. Most of us would be thinking along this direction, but it is also interesting if you think in this direction. For example, there exists some x, C of x implies d of x. Okay. It's not that different from the left-hand side. It looks pretty similar, isn't it? What I mean by that is more precisely, this is the left-hand side expression and this is the right-hand side expression. I'm asking, are these two things equal? Pause the video and think about it yourself. Can I model this, some camels or ducks, this fashion, like the left-hand side? Or should I use the right-hand side idea? It's not that immediately clear. Let's ask the solver. Now I'll create a generic object. I will create a function for modeling the camel objects. Is a mapping from object to Boolean. Something is a camel or not a camel. Something is a dog or not dog. I need to create a free variable to model there exists. So the left expression that I wrote it on the whiteboard is there exists an x such that C of x and d of x. And the right expression is there exists some x implies C of x, d of x. Okay, now we create a solver object. And we ask the solver of these two expressions. Okay, I made a small typo. It's called right expression, but anyway, let's leave it like this. We have to now check. Okay, it shows shat. That means left expression is not equal to right expression. Let's ask for the model. I'll explain to you how to interpret this model. Consider this x. X is just generic object, right? Some generic object. Don't worry about this exclamatory val, exclamatory zero. You just have a generic object. That's basically what you have. Everything else is considered not a camel. That's the meaning of this. Any input that you send into the camel, you always get back a false. Okay. What it means is that C of x is always false. That is the meaning of this portion. Okay. It's always false. D of x is always false. But let me now evaluate the left-hand side and the right-hand side, right? So we have the model. Let's copy the model into a variable called model. And let's evaluate the model. Left expression first. What you get is there exists x is false. Okay. Left expression is and, right? And of C of x and d of x. It's false, as we can imagine, because everything else is mapped to false here. Simple C and dog, both of them are always false. Okay. What about the right expression? Typo, that's why I'm not typing the right correctly, but that doesn't really matter. It's just a variable name. You see, it's true because false implies false is actually true. From a false hypothesis, you can arrive at any conclusion you want, including a false conclusion. Therefore, the right-hand side became true. Okay. So to sum up, what have we done so far? We proved that those two expressions are not equal. We found a model using C3 that had false here always for that particular definition of C of x and d of x is always false. And here it became true, but true and false are different. Therefore, they are not equal. Okay. So what it means is that if you're using there exists, right, these two expressions are different. Okay. So which one should you use then, right? Think of this way. Some camels or ducks actually mean there is some overlap between camels and ducks. Okay. So you have two sets. You can view it as a Venn diagram. You have all the camels in the world are here and all the ducks in the world are here. But some camels or ducks imply there is some overlap. That's the meaning of this statement. And that is better model using an and. This is called and, right? This is intersection. That is the reason you're using and. There are some camels that are present in both, not all. For example, over here, these things are not here, right? On the other hand, if you model it like this, as you can see, if this is false and this is false, right? The overall expression became true. What it means is that if you take now, let's say, a duck that you know for sure exists, and you know for sure in our world, camels are not ducks, right? So what happens if you put that duck here in d of x? That will be true. We also know from our real world that this is always false, okay? Because there doesn't exist a camel that is a duck. If you use this in the left-hand side expression, c of x and d of x for any x, this is going to be false because it's and. False and true is false. But if you substitute this here, this is false and this is true. False implies true is actually true, because from a false hypothesis, you can arrive at any conclusion, including a valid conclusion. So what it means is that if you model some camels or ducks as there exists x such that c of x implies d of x, you can actually arrive at a true conclusion, although we know for sure this is always wrong. This can never be true unless some evolution theory comes and says camels are ducks, but that may be too far of a stretch. But as you can see here, you have a false statement. If you model it using c of x implies d of x, you can arrive at a true conclusion because false implies true. But if you use the left-hand side expression, you can never have that contradiction. Okay, so that's basically it. Thank you very much for your attention.